Arul, the stage is yours, my friend. Go for it.
Good morning, everyone. I'm Arul Jegadish from OpsVerse. I'm one of the co-founders of OpsVerse. We are a startup that offers an end-to-end DevOps tools platform. So today I'm going to talk about a recent project that we took up where we migrated some of our data workloads to ClickHouse. Next slide, please. So the purpose of the discussion here, so one of the components in our tools platform is a full stack observability stack. And as part of the observability stack, one of the modules is distributed tracing. And for distributed tracing, we use the tool Jaeger. And Jaeger has different storage options. To begin with, we use Cassandra as the storage option, and then later migrated to ClickHouse. So this talk here is about why we did that and how we did that. Next slide, please. So first of all, a little bit about Jaeger. If you heard about Jaeger, it's a OSS tool for managing distributed traces. It came out of Uber, and it's actually part of CNCF now. It's one of the CNCF incubated projects. It's very, very stable and widely adopted. With Jaeger, if you have a distributed system with several microservices, you can get a full unified view of your system when a request goes through your system. So that's about Jaeger. Next slide, please. Yeah, and a little bit more about the architecture of Jaeger. You actually begin by instrumenting your applications to emit these traces. That's usually done with, nowadays it's done with OpenTelemetry libraries. And then you collect those traces, send it to the backend, and Jaeger processes it, and finally stores it in the DB, the Jaeger DB. The common storage options are Elasticsearch and Cassandra. In our case, we started off with Cassandra as the storage engine. We didn't want to run a bunch of Elasticsearch clusters. Cassandra served us really well till we wanted to do more with the data. We wanted to do a lot of analytics on the trace data that came into our backend. So then we started looking at other options. Next slide, please. A little bit about, again, Cassandra's some advantages, disadvantages. With Cassandra, the ingestion was really fast. We were using a Kafka. The lag on the Kafka was like really almost zero. So the ingestion was really good. But on the disadvantages side, we couldn't do much analytics on the data. So that was a main requirement for us. The other disadvantage is the resource usage with Cassandra with respect to storage, memory, CPU was pretty much on the higher side. And we were running this at scale, so we were looking for a more optimized solution. So next slide, please. So that's when we actually looked at ClickHouse. With ClickHouse, the analytics capabilities were really good. We were able to really do a lot of analytics on the data that we collected with Jaeger. Plus some of the storage optimization with ClickHouse was also really important for us. We were able to do a lot of analytics on the data. And some of the weaknesses around ClickHouse didn't really affect us for this use case because the tracing data is pretty much immutable. Once you collect it, you're going to delete it only when you are like over the retention period. So that was pretty much okay for us. Next slide, please. Now the other aspect of ClickHouse is other aspect of using ClickHouse with Jaeger is Jaeger has a plugin built using the gRPC support to support different type of storage. So we basically use that. There is a plugin published by the community called Jaeger ClickHouse that actually supported the ClickHouse backend for Jaeger. So we were able to make use of that and make Jaeger write data to ClickHouse. Next slide, please. At a high level, some of the steps that we used. The first thing is to run ClickHouse on Kubernetes. So we use the Alternity ClickHouse operator. So the operator has a lot of community support. It pretty much worked out of the box for us. The Alternity guys have done a really good job in bringing out that operator. So if you're going to run ClickHouse on Kubernetes, that's a great choice to have. We run a lot of production-grade workloads using that operator. So in this case, the other aspect is we use Argo CD to run our entire platform. So in this case, the steps are really about making changes to the Argo CD configs to swap Cassandra out and bring ClickHouse in. And bringing ClickHouse in is basically through the ClickHouse operator custom resources. And then it's just about changing the Jaeger configuration to use ClickHouse as the backend. We also had production data in Cassandra, so we had to migrate that data to ClickHouse. So for that, we basically used our own custom script. This is something I can talk about in detail, maybe offline, on how we actually accomplished that data migration. Next slide, please. So some best practices and some things we noticed when we did this migration. First of all, the ClickHouse operator that actually ends up creating a load balancer by default, which is something you might not want. Your ClickHouse is something you'll access only from within your cluster most of the time. So that's a setting you may want to change before you go to production with that. The other thing is you may want to create a read-only user, because if you are going to visualize your ClickHouse data on some visualization tool like Superset or Grafana, having a read-only user helps. So you may want to change the configuration to create a read-only user. And similar to that, some basic changes like change the retention period, disk space, and request and limits for resources. These are things that you may want to change. The other important thing here is we were using Argo CD. So Argo CD is also a controller. Now you have a ClickHouse operator that is also controlling some resources. Often these two controllers get into a conflicting situation where both the controllers will try to manage a resource, especially like PVCs and PV. So you may want to take care of that. Otherwise there could be some unpleasant surprises where Argo might try to delete your PVC. So before you go to production, this is something you really need to take care of. Next slide, please. The next stuff is really about making sure you're backing up your data and monitoring your instances. So for backup, again, there is a great open source tool, ClickHouse-backup. Currently, we run it as a Kubernetes cron job. Interestingly, this is also becoming a custom resource as part of the ClickHouse operator. It makes it even more easier to create backups of your ClickHouse instances. And secondly, you can have ClickHouse expose Prometheus metrics, and then you can scrape it. And once you scrape the metrics, you can create dashboards and create alerts. So we have this done, and you can also get it done fairly easily with these open source tools. Next slide, please. Once you have all this set up, this is really showtime. You can query your data and create really good dashboards. All you have to do is connect your ClickHouse to one of the visualization tools, Apache Superset, RedHashDB, Grafana. These are all great choices. And all these tools have out-of-the-box connectors and data sources available to connect to ClickHouse. So you just have to connect that and then start writing queries and create really good dashboards. In our case, with respect to Jaeger, the Jaeger's data model was pretty flat. It wasn't really optimized for querying. So we used ClickHouse materialized columns to create a few more materialized columns, which made it easy for us to query the data as well as it improved our query performance. Next slide, please. I'm going to skip the demo here. If you have if you want to look at some demo, I'll be happy to show that offline. Basically, what this allowed us to do is it actually allowed us to give our customers a really good APM solution on top of open source Jaeger. So open source Jaeger is really good. It collects traces, and you can view your traces, but then there's no analytical capabilities. So we took the data to ClickHouse, and then we created an APM on top of that data. So that's what we were able to do at OpsVerse. Next slide, please. So yeah, I mean that's what we have to share here today. So if you have any questions, connect with us. Connect with me on Twitter. Find me on LinkedIn, or find me here. I'll be happy to chat more about this topic. Yeah, like I would like to thank the organizers for giving us an opportunity to present here. Thank you.
Thank you, Arul. Good job. Awesome. We do have time for a question. If we have any questions in the audience, anybody got a question? Questions? Let's see. Well, with that, then, we do have a question. Awesome. Give me an excuse to run. Exercise is good. Thank you.
Thank you, Arul. So you kind of mentioned about contention between the Argo CD operator and the ClickHouse operator. Can you talk a little bit about what exactly was going on?
Could you please repeat the question?
You mentioned a little bit about the Argo CD operator contending with the ClickHouse operator, and can you talk a little bit about what you saw?
Sure. So what happens is with the ClickHouse operator, the Kubernetes resource that you will create is a custom resource. Called as like ClickHouse installation. That's the kind that you will create. So Argo CD will manage that, meaning Argo CD will take the configuration from Git, apply that to Kubernetes, and will actually manage that. And once that resource is applied to your Kubernetes cluster, then the ClickHouse operator running on that cluster will look at that resource, and it'll do a few things, right? It'll actually launch pods, it'll create PVC and all that. Now, what happens is, if you don't set the right annotations and labels to be propagated down, Argo will start thinking that these are extraneous resources. Argo thinks that there is a PVC now here, this is not defined in Git, so I should go delete it, right? If you have like auto pruning setup, auto heal setup, then Argo will actually try to really delete your PVC. So if you don't take careful action, that can happen. So before you go to production, ensure you test it and ensure Argo and this operator is good. This actually happens with even other operator type setup with Argo. You have to ensure the right annotations and labels are propagated. Yeah. Okay.
So with the pros and cons slate that you had, so you identified some cons with the Cassandra, right? And you went with ClickHouse. So did you explore any other option, any other solutions that you had other than ClickHouse?
Yeah, so a couple of other, initially there was even a time when we thought about even using S3 as our backend. That was not a very good option, but we were thinking about saving cost and all that, looking at S3. Jaeger supports even S3 storage, but we didn't go down that path. Analytics, it's not the right solution for analytics. There is Druid DB is also another option. We didn't do a detailed POC there. ClickHouse worked really well for us. The team also had prior experience running ClickHouse, so we actually went with ClickHouse. Druid is another option that you can actually explore for analytics workload.